The world that we work in has very serious consequences when things fail. And I'm not willing to bet my family's life on the fact that we're not ready to defend against technologies that continue to advance because we weren't willing to invest in it ourselves.
Hello, and welcome back to Quantum Matters, where quantum computing gets real, from D-Wave. I'm your host, Murray Thom, as we move past the hype and the theoretical to explore practical, real-world applications of quantum computing today, and where the biggest opportunities lie in the future. Let's open the box and see what's possible. So far on Quantum Matters, we've explored optimization across logistics, manufacturing, and robotics, but today, we're stepping into the defense sector. On this episode, we're looking at how quantum computing is being applied to mission-critical national defense, specifically in air and missile defense planning, where critical decisions must be made at scale and under time pressure. The advantage of quantum hybrid in this case isn't theoretical, it's operational. It's what enables improved threat mitigation using a fraction of the time of other solutions when evaluated in highly complex scenarios. Here to tell us all about this fascinating work is today's guest, Dale Moore, President and CEO of Davidson Technologies. Davidson is working at the intersection of advanced defense systems and emerging technologies, collaborating with Anduril and D Wave to develop quantum hybrid solutions for air and missile defense. Dale, welcome to Quantum Matters.
Thank you, Murray. It's a pleasure to be here.
Dale, I'm going to begin by asking you to tell us about Davidson Technologies and the work you do there. And I think people might get a bit of a chuckle because you're the president and CEO of Davidson Technologies. So they might think, hey, he just runs the place. But I also think they would really appreciate hearing you speak to it.
Well, let me first give you just a quick overview of who Davidson is and what we do. Davidson is a 30-year business that has always been focused on very complex national security problems and developing technologies that solve them. We are focused as we move forward on advanced technology implementation. And so our mission is to innovate with purpose, deliver with speed, and empower the warfighter. And so what you see from Davidson on a daily basis is going to be focused on those three things with a vision really to enable secure information dominant solutions and decision advantage algorithms and really solving very complex warfighter problems. My job as CEO, obviously the simple answer is yes, I run the business. Yes, I'm responsible for the success or failure of the company. But more than that, we are striving to be one of the best companies in our space, both from a technology standpoint and from a culture standpoint. And so I try to set every day an example of what that means. And it means obviously hiring great people, empowering them to do their jobs in support of our customers and the mission spaces. But it's also about creating a culture where elite talent thrives. And these types of problems energize our business and the employees who work for us. And so I have multiple jobs in this company to include, chief growth officer, chief financial officer, president, CEO. But we're a small business, and so that's just what it takes to keep things going. But excited to be here, and I appreciate the opportunity to have a chat.
That's right. You've got your hands in the work and working alongside folks. I definitely feel that as well, working at D-Wave and the size that we are. Now, I think a question that's you're going to be able to provide a unique perspective on here is that, from the CEO's lens, how did you get started in quantum computing and why was that initiative important?
As we were maturing the company and really looking at, how do we as a small business differentiate ourselves in a very competitive market space, we felt like that quantum was going to be a future enabler, and we're starting to see that certainly. But it just made sense for us to, one, it was a good fit from an optimization standpoint and some of the algorithms that we have been focused on developing for decision-ready solutions and advanced compute platforms. It just made sense to combine these two. And we were very interested in how quantum, as it matures, will be an enabler. The one thing we didn't realize was that there was an actual operationally, commercially viable system out there. And that's where the partnership with D-Wave became very, very obvious.
Yeah. Well, and I think that perspective on like really accepting the challenge that emerging technologies present in terms of understanding them, learning how to use them, as well as bringing that near-term application focus. I think that's such a strong point for Davidson, and also such a valuable role in terms of the work that you do in the defense industry sector. Dale, right at the top, I mentioned the application of air and missile defense planning, but I think that most of the folks in the audience, certainly, it was very new to me when we started talking. I mean, can you give us a description of that application and maybe like how it gets broken down?
I'll try and do it in the simplest as terms as possible because it is a very complex subject. But the bottom line is missile defense in itself, integrated air missile defense, is all fundamentally based on defeating ballistic, non-ballistic, and other types of threats. Think drone swarms, etc. And the fundamental premise is you have an area. It could be the size of a country. It could be the size of an island. It could be any given size, but you've got something there, an asset that you are trying to defend. And so you have various means to do that. And in the missile defense community, we generally kind of bundle different what we call effector systems. These are actually the weapon systems that drive the interception of the various threat complexes. They can be broken up into what I would consider an upper tier, a middle tier, and a lower tier. So there's a layered defense approach to defeating any kind of threat that could be applied against what we call a defended area. And so you place effectors, and you can place them in many different spots. What's the best placement of those effectors? Oh, by the way, you also have sensors. Well, the sensors are what feed the effectors their firing solution fundamentally. But each of these effectors have limited inventory. And what you have to do is figure out how to optimize the placement and the prioritization of the defended areas, particularly if you have multiple defended areas that you're dealing with. And so it becomes a very complex optimization problem of where do you place the effectors? How do you prioritize the defended areas and utilization of the effectors against various threats? There's other things that come into play, geometries, angle of attacks, things that matter in the context of how effective these weapon systems are from a performance standpoint. So we're able to evaluate that depending on the location of the threat when it's fired upon. And all that is driven by the sensor engagement and the command and control information that the weapon system receives. So it's a very complex scenario. Again, these chain of events happen very, very quickly. Again, we're talking a matter of minutes in some cases. And if one part of that chain fails, it becomes very problematic to get a high probability of success and engagement.
Well, thank you, Dale. I mean, I certainly felt it was a very difficult application before, I understood it, to a greater degree. And that point you're making about a layered solution and being thoughtful about your inventory and the resources that you're allocating, it's a very challenging resource allocation problem. And I think we have worked together, Davidson and D Wave. We've got this new partnership that we formed between Davidson, Anduril, and D Wave to look at this kind of problem. Can you tell us in terms of like the progress in that project and the results that we've seen so far?
Absolutely, Murray. Obviously, missile defense has become a pretty important topic around the world. And so we thought quantum could be an enabler for better solutions from a planning standpoint and an asset allocation standpoint for effectors and sensors, which are the main drivers for how a complex kill chain like missile defense gets executed. You need something particularly with a very large scale type of scenario where you're defending a large area. You have a very large amount of threats that you have to potentially defend against. How do you do that? And that becomes a very complex problem at scale. And so we thought it was a good opportunity to leverage quantum and actually benchmark a quantum hybrid solution versus a classical solution. And what we showed was that quantum has significant performance value over the classical solutions in this project. And so we ran a number of scenarios, some of them at lower threat complexes and lower number of assets, all the way up to a very, very complex scenario with over 500 threats and hundreds of assets that both effectors and sensors that were defending this area. And we found a 19% improvement on the quantum solution over classical for negated threats, which means we basically were able to shoot down around 19% of the threats that were fired in these scenarios. And this was all modeled. Obviously we're talking simulations, and we were able to prove out for the first time since we've been talking about quantum and working with D-Wave in a real use case, a real scenario that our customers care about. So think about, these are missiles, drones, cruise missiles, ballistic missiles, all types of technologies that if not negated in a scenario that involves, a potential impact in a public environment, a population center, industrial complex, whatever it might be, can have a significant impact on both human mortality as well as, the amount of money and impact on an economic environment, et cetera. So these are why these things are important. And for the first time, we now have data that proves out quantum-enabled, quantum hybrid solutions compared to classical algorithms in this scenario can achieve better and more efficient planning optimization activities against the classical solution. So it's a big win for us.
I mean, it's phenomenal, Dale. I mean, precisely in the scenario that you're talking about, I'm a little bit of a nerd. I'm sure people won't be surprised. And, I remember watching Neo in The Matrix, when the movie The Matrix came out, and to have that power to kind of be like, to put your hand up, and stop the bullets as they're kind of arriving at you, it's a game changer from the perspective of, well, what does that mean in terms of people's security? What does that mean in terms of the ability to bring diplomacy, to talk to folks, to kind of resolve things, and being able to arrest any kind of attack that's taking place like that, and then basically just create that kind of pause. It's so valuable. And we've learned so much in these asymmetric threat scenarios where it's like, well, it's just one missile, but it's taking out a piece of critical infrastructure, which takes years to replace, and so, being able to have that capability, and just as you're saying, seeing that improvement in terms of the number of, threats basically mitigated is remarkable. And can you tell us a little bit of what was it like? I saw the presentation from Torsten Staub and Patrick Gemperlein. What was the recognition, that the aspect of this problem where it was clear, oh, this is actually a pretty good fit for quantum hybrid?
Yeah, certainly from our standpoint, it was really what are the optimization use cases that really fit, in particular, the quantum annealer, the D Wave annealer. And this was one of those that just kind of stuck out, right? We knew missile defense was an important topic. Davidson has a long legacy in missile defense technology development and problem solving. Anduril is a, obviously frontline, not necessarily an S&T company, but very, very R&D focused and very focused on solving complex problems. And so it just made a lot of sense. And, over the last 50 years plus, the U.S. has been working on technologies to defeat various threats around the world in ballistic and non-ballistic missiles. And now it's drones and swarms of drones. And, there's, and certainly it's going to evolve. And, how do you cost effectively defeat a swarm of drones that could, cost $30 a drone, as an example, versus a multi-million-dollar missile technology. So you got to be very efficient in how you use your resources and the inventory that you have, because the reality is there's only so many in the hopper, and so you got to maximize the use of that missile technology. And it's like hitting a bullet with a bullet. That is it's an analogy that's used often in relation to how missile defense technology operates and how do you defeat that type of threat. And quantum is something we're going to see that enables that technology and those systems to get better. And that's what I'm focused on. And I think Anduril is certainly in the same boat. So it was just a good partnership that made a lot of sense. All three companies invested in, how do we do this the right way? We wanted it to have value, not just for us, but also for the market space and for our customers. And I think we're starting to see advocacy from that presentation and from those results that are going to continue the experimentation and the understanding of how quantum-enabled solutions can provide real value to our customers.
I think that the real value to your customers is the key point there, and helping them to find exactly the places where quantum hybrid is going to be relevant to them, because it's not doing the whole workflow, right? It's not analyzing the locations. It's not, prioritizing the locations. It's helping to solve a resource assignment problem, and that's so central to this application. And specifically with regards to, where are you going to be placing sensors and effectors and what combinations, I've seen examples in the commercial space in terms of how do you assign human resources to tasks within a business in order for them to basically meet the demand that they're expecting, or in automotive production in terms of how are you going to be assigning the sequence of tasks you're going to be doing as you're producing vehicles. So there's that thread of connection that I'm seeing there. And in fact, I've also seen an application from the North Wales Police Force where they have a set of forces who have to respond in emergency scenarios, and they're looking to affect by reducing their average response time, by correctly positioning them to be able to deal with, and respond to callouts. And through work that we've done with them on a project, we've been able to show in a simulation that they expect to be able to reduce their response time by nearly 50%. This is a very closely connected problem. And I think that, building on this and then thinking about the defense industry, there's so many applications this could connect to. I'm wondering if you can tell us more about some other use cases you've got your eyes on at Davidson in that space.
Yeah, absolutely. I mean, we are obviously going to continue to invest in the application side of how quantum platforms and quantum-enabled solutions drive success for our customers. I think when you look at some things that are going on today, obviously DARPA's got a quantum benchmark initiative that's ongoing that is really looking at the platform side and how the hardware and the evolution of quantum computing in essence, whether it's annealing or gate model, is moving forward. And so we're going to be continuing to monitor the outcomes of some of those initiatives. When you think about optimization opportunities within the spaces that we work in, one that comes to mind certainly is, I mentioned the complexity of these systems, and the complexities of the threats continue to increase. What that drives fundamentally is more data. And so data is the essence of everything that we do. And so the more data you have on the networks that connect, let's just say joint all domain command and control as an example, how much data becomes too much for you to even be able to get to a point where you can make good decisions with the data you have? Or are you dropping data that is not being enabled to actually help very quickly solve a very complex problem for a potential solution for a warfighter? Quantum-enabled machine learning, as an example, could be a significant enabler of how to fuse and utilize all the data on these networks in a way and that both is informative and rapid for what ends up being a very complex and very dynamic environment. I mean, the reality is war is fast moving, right? And even in the missile defense world, I mean, you're talking, minutes when it comes to ballistic threats and hypersonic threats. You got to make decisions quickly, and so when you're leveraging capabilities that can see things and transmit data across a very broad network, that network being space, air, land, around the world, moving very quickly. How can we better enable people to understand what's happening and utilize that data to really engage, a potential threat and fundamentally negate it?
Yeah, just as you say, getting that data, reviewing it, being able to make critical decisions about it, and then also recognizing that you're marshaling an enormous amount of resources in response to it, right? And orchestrating those to the greatest effect, is so important. So I feel like, that's so powerful, and I'm really looking forward to being able to work with Davidson to sort of learn about those and help kind of create those opportunities. Now, it's, I think, important for folks to keep in mind here that there's also an aspect of, how do these systems fit in? That's probably going to be a question on a lot of folks' minds in the defense space. And, in this project with Anduril and Davidson and D-Wave, there was an opportunity to actually start to put the components of a system together. So how is, workflow integration factoring into your thinking about these defense use cases?
Yeah, I think it's critical. The real bottom line for us is how do we prove the value of quantum-enabled solutions for our customers? And so the workflow piece is critically important. And it really, from a capability standpoint, everything has to have a reason to be there. And, the context of how we utilize these capabilities is extremely important. And obviously, understanding the use cases that drive the right, I would say, experimentation with quantum-enabled solutions is critical, and so that the workflow comes into play there, right? How are these pieces going to fit together, and is it the right solution and the right problem for quantum-enabled? Again, the reality is, classical is not going away anytime soon. It may never go away. There will always be some reason to leverage classical algorithms, but when you talk about workflow and where things are going, right, the idea of really complex scenarios being realistic and the risk that something breaks in the workflow process, right? This idea of, okay, we've got a chain of things that have to happen in order to achieve a negation of a threat. And if one of them doesn't work the way that it's supposed to, you're going to fail. And do you risk enabling that failure because you're not willing to underpin your solutions with a quantum-enabled solution that will not break and can solve very complex problems much faster than classical compute can in certain cases? And so, the reality is, we want to see our customers' success. And we believe that eventually underpinning all the classical solutions we have in place today with a quantum-enabled solution is going to be the answer. And so that's what we're focused on developing.
Yeah, I think, that point you're making, which is like the mission success is critical. We can't afford to fail. We know that classical systems have limits. There are certain types of problems where they will do exceedingly well, and we're taking full advantage of them in those cases. But there are other aspects of these problems where they struggle and they slow down. There have been, surveys done, let's say like Wakefield performed a survey in 2025 where they found that 81% of CEOs felt that they had reached the limits of what classical computing could offer them for optimization problems. And so for these mission critical applications, are we just going to accept those limits and basically just work around them and accept the failures where we can't basically, move into those spaces? Or are we going to bring these new technologies to bear, like quantum computing, and bring that technology together so we can now, expand and broaden our robustness in terms of our response? I'm thinking about the fact that, Davidson is the host of a D Wave Advantage2 system. It's one of the first US-based Advantage2 systems that are available. And I'm curious, what has it meant for Davidson, and for Alabama more broadly, for you to be the host of a D-Wave quantum computer?
Well, let me say this. One, it certainly is an advantage for Davidson in the context of just the visibility and the understanding of who we are from an advanced technology standpoint in the market that we're in. I think it's a great fit for the ecosystem and the environment here in Huntsville, Alabama. A lot of people don't know about Huntsville, Alabama, but if you don't, it has been a bastion of technology, research and development, and really advanced technology implementation for a long, long time, going back to World War II post through the Apollo space program, Really, missile defense technology was foundational and really discovered and innovated here and continues to today. This is the legacy of Huntsville. This is what we do. And certainly the state of Alabama, Huntsville is a key part of the economic foundation that makes Alabama work. The other thing I'll say on bringing the system to Davidson's headquarters here in Huntsville is there is a lot of healthy skepticism in our customer base around what quantum actually is today. And is it theoretical still? Is it is there operationally relevant solutions? Is there an actual quantum computer that is real, that is sustainable, can be utilized? And so we got those and continue to get those questions all the time. But the one thing that the system here in our facility does is, one, it enables people to actually see that there is a real quantum computer that is operationally viable. You can access it, touch it, utilize it, but it kind of opens their eyes around the realities of quantum is not a 10-year away technology. It exists.
Well, and I mean, Dale, I think that the point that you're making here about skepticism and questions, in the defense sector and then, in the world more broadly, I mean, it's natural for people to have questions. It makes sense. And, it's about, well, let's identify the questions like, what is a quantum computer? What does it look like? How can you know that it's using quantum effects to perform these calculations? How much faster can it be than classical computers? What kinds of applications can it work on? So, I mean, I think having the questions is an important part of somebody's journey. And the great thing about having that system there in Huntsville, Alabama, is that it creates an opportunity for folks in their community. And I mean community more broadly, including the local industry, where it's like, yeah, there are folks that who are pursuing the answers to those questions, finding the applications where this provides fits, that are running the experiments to show the performance differences that they're seeing with, classical only systems and quantum hybrid systems. And, we're a social species, right? And that experience, that shared experience with our community, I think is what helps folks to feel that it's tangible. This is groundbreaking work that you're doing, and it's removing barriers to make innovation in the defense sector easier. And I'm going to ask you, like, when you're out in the field working with your colleagues in the defense sector, and you're talking with them about the work that you're doing and helping to make it relatable for them, can you share your thoughts about like that important role that you individually, but also Davidson, the organization you're representing, are playing in the defense industry and doing this work?
One of the reasons we partnered with D-Wave to get the system down to our facility here in Huntsville is focused on the things that you're talking about. And fundamentally, I mentioned earlier, data drives everything. Unfortunately, in our world, data goes to different levels of classification very quickly because of the environment that we work in and the sensitivity of that environment. And so it's really important for us to be able to leverage these types of systems at what we call an accredited level, which means there's been a full evaluation of what you mentioned, tiered access, overall access controls, compartmentalization. There's a number of things that go into how you accredit a system for classified operations. The facility has to support it, which is something that we invested in here to ensure that we could bring the computer to a level that would actually add value to our customers. And from my perspective, I don't know of one, and I could be wrong, but I don't think there has been a full up quantum compute accreditation for classified processing within the Department of War in the United States. And so we're trailblazing, to your point, on things that nobody else has done before. And in order to, I think, to add the maximum amount of value and really enable the exploration of how the use cases and the platforms and the applications can solve our customers' problems, it's going to take getting to that level and being able to operate in that environment. And so we are very focused on that. And we have customers interested in helping to get there because they want to see how that value can be brought to bear. And the reality is this, I mean, and I would say this to anybody, Murray, the world that we work in has very serious consequences when things fail. And I'm not willing to bet my family's life on the fact that we're not ready to defend against technologies that continue to advance because we weren't willing to invest in it ourselves. And so that's entirely Davidson's purpose for being here. It's all about how do we ensure that the population of the United States and our allies are protected in a way that I can go to sleep well at night because I know that we've done everything that we possibly can to stay ahead of the curve, to bring advanced technology to the solutions and provide the warfighter with the best possible answer to the problem sets that they're dealing with. And quantum, I believe, is going to be a game changer in that regard.
Well, and thank you, absolutely for doing that. I mean, because it's not, it's not a place that I can fill, and so that's just shows the importance of working together as industry and these partnerships that we're forming, right? Because it's, your relationships, your knowledge of that space, the fact that you have a track record of delivering high technology solutions in that space, that's really, I think, what makes that possible. So, I mean, that's so meaningful for me, for personally, and I think also for everyone at D-Wave. Let's turn to, the perspective of the defense industry and the commercial sector here, which is that, there have been a variety of high technology products that have been built. And sometimes it's the defense sector that's leading them, and the commercial sector actually gets some benefits and learns how to basically pull it into civilian use cases. Sometimes it's the commercial sector that blazes ahead, and there's opportunities to then draw that innovation into the defense sector. As you're looking at quantum computing, and certainly the history of quantum computing hasn't been written yet, where do you feel we're at right now?
Well, I do think that the commercial sector is ahead of the game today, and how they're utilizing quantum applications. And certainly, I think that's somewhat centered around what is the best fit today. And from a use case standpoint, the commercial sector has problem sets that are, I think, very viable and very legitimate relative to how quantum empowered solutions can actually add value. A lot of what we do in our business are, there's a lot of physics-based aspects, nonlinear computations, and so the challenge there is how do you fit what is in existence today to make that work as well as it needs to. But there are some very real, as we've talked about, applications that make sense for what's viable and operational today. I do think that paradigm is going to shift over the next 5 years, but I think you're going to find that there are many use cases that fit a various technology and platform utilization that maybe don't work well on another. And so, but you're going to have different technologies that drive the right kinds of functionality for the right use cases. And it's going to be a multiple fabric, I would say, of quantum ecosystems that help enable the things we're trying to do. And so we want to be at the forefront of that and helping our customers figure out what that looks like, and working with partners like you to better enable those things and those decisions to impact the future of national security in this country.
Yeah, well, I couldn't agree more. I mean, I think that at D-Wave even, it's very clear to us that different quantum computing technologies basically have very different uses and different strengths. It's sort of I think the question can sometimes be confused, like, is a quantum computer general purpose? Is it universal? I mean, the fact of the matter is that all of the quantum computers that we have that are in existence right now, we could try to solve any problem with them. They are Turing complete from a computer science point of view. But that's less important than can they accelerate the application? Because we already have readily available classical computing technology. And what we have found is that, different quantum computing platforms, including that's exactly the motivation for D-Wave having a dual platform strategy, is because we know that optimization really requires like an annealing model of quantum computing. We also know that important, quantum chemistry, molecular simulation applications really require gate model. And so, we don't know the whole future that's laying ahead of us, but we're going to be working and watching closely and developing those technologies as they grow, as you are. Now, let's use that to look ahead, look towards the future here. Based on your 26 years of experience in the defense sector, what is your view of like what the future looks like for quantum computing innovation in defense?
Yeah, so I think there's a lot of different areas there, and I think it's going to be interesting to see particularly gate model and how it shows up over the next 5 to 10 years, and the stabilization of that technology from a noise standpoint. But I do think there's some very relevant problem sets that you're going to see quantum enabled solutions have a bigger impact in. I would look at cryptology and post quantum cyber. That's going to be a big focus of certainly the U.S. government, and understanding how our encryption technologies show up against quantum enabled decryption technologies. I think material science is another area where you're going to see some advancements. And I think you guys have already shown some value in some of the work that you've done around material science. I think that's going to continue to grow, right? I think space is going to be a significant opportunity space for quantum enabled solutions, right? The proliferation of space continues, particularly in the LEO orbital regime. The more that gets up there, the harder it's going to be to deal with debris, optimization of routing, how you control and command and control of all these different systems in space, how you defend them. I think precision navigation and timing is certainly an area where there's a lot of interest in how quantum enabled technology can improve and make it more resilient and robust. So I think, and I mentioned earlier, there's certainly an area in advanced machine learning and quantum enabled machine learning, and training of models with very large data sets, and how you deal with data fusion and just the big data problem that exists on command and control networks, particularly at all domain levels. So trust me, there's a host of opportunity space out there for quantum exploration and quantum solutions to be a part of the solution. Quantum communications is another one. You're going to see a number of things, I think, start to develop on that front as well.
Yeah, I don't think I could have said it better. And it's interesting. I mean, you're pointing through a variety of future applications there, from cybersecurity through space and systems management, precision control, machine learning. I mean, and some of those, when you consider the offset of cybersecurity versus like solving complex problems in space, you've kind of got flip sides of the coin. And this reminds me of a famous quote that I read from Isaac Asimov. Isaac Asimov was, a famous science fiction author on books about robotics. And his point, he said, when he was reading books about robotics, it was like all of the narratives were the same trope. It was like man invents robot, robot kills man. And the underlying message there was that new knowledge is dangerous, and certainly from the cybersecurity standpoint, it's like, okay, if we develop quantum computers, we still want to be able to have good encryption protocols for the messages we need to send. But, his question was, what is the answer to that? Does that mean we need to retreat from new knowledge, or is it possible for us to use that new knowledge so that we can accentuate the benefits, solving those complex problems, and mitigate, whatever potential negatives there might be in terms of, threats to cybersecurity. And I feel like, your point about, the partnership that we're forming and the working together between Davidson, Anduril, and D-Wave being the tip of the spear, it's about doing that important work and helping to define that. Now, we're going to turn, let's say, to my final question here, and recognizing that if we imagine like the community of folks working in the quantum computing industry being inside a circle, most of the world is outside looking in, and wondering if they should step inside the circle. As someone who yourself has been working in the space now, you've garnered some experience, you've got some knowledge, I think a good question for you to answer, which will speak to the experience of the listeners, let's say, who are themselves, considering that move, what advice would you have given yourself when you were just beginning to explore quantum computing?
I would take that risk again in a heartbeat. I think, again, anytime you're, particularly as a small company, anytime you're on the cutting edge of, technology and research and development on a particular application or platform or whatever it might be, there's risk. And so I would say absolutely do it again. Again, getting back to my point about, we can't sit idly by and let the world pass us by from a technology standpoint and the world that we work in. we have to stay at the cutting edge and have to stay ahead of our adversaries. The way you do that is by continuing to evolve technology, continuing to take chances on things that you believe are going to have a significant impact in the mission areas we support. And so I would absolutely go back and tell that Dale that you're doing the right thing. You need to make this investment. You need to take this risk. It's going to pay off. We're 4 years into this, 4+ years, the partnership with D-Wave and exploring quantum technology. We've made a ton of progress. We've had a lot of success. We've got a benchmark project now with you and Anduril that proves there is real value there for certain very complex use cases. And so I think it's a building block for where we're trying to go. And we're going to continue to make those investments and continue to utilize quantum technology in a way that is different than anybody else out there.
Yeah, I really appreciate that. I mean, I think it's absolutely real and sobering, the point about, there is risk in any new technology when you're looking to change and innovate. You're trying to find new and better solutions. But what a clear perspective you have in terms of the risks of not doing that innovation, right? It's just not worth it. And I love that spirit, right? I'd take that risk all over again. So Dale, it's been great having you on the podcast. Thanks for being a part of Quantum Matters.
Thank you so much, Murray. Appreciate your time.
What a fantastic conversation with Dale Moore, President and CEO of Davidson Technologies. And certainly everyone at D-Wave Quantum appreciates the partnership with Davidson and with Anduril. Quantum computing is a technology that's looked to create innovation. And we're certainly seeing innovation in the commercial sector in our businesses and helping them operate more effectively. But it's also important to recognize that's really critical that we also make use of it in the defense sector, which is about ensuring our security. And I appreciate the point that Dale was mentioning, which is that, yes, it can be risky, it can be uncomfortable when we're taking the path of innovation to change, to find our way to better solutions. But we have to also consider that clear perspective on what is the cost on failing to innovate and making sure we take that journey and those important steps in order to bring those new advanced solutions to those important missions. That's it for this episode of Quantum Matters. Thanks to you, our viewers and listeners, for joining me. Please follow so you don't miss an episode, and to learn more about how D-Wave works with organizations to get started and succeed with quantum, visit the link in our show notes. Until next time, I'm Murray Thom. Stay curious about your quantum reality.